AOPS, volume 1, the basics, number 72. In a closed bottle, the product of pressure and volume is constant. By what percent must the volume be decreased to increase the pressure by 25%? So, as always, utilize the information that we're given with. We get the pressure modeled by P times the volume should give a constant of 1. But we're told that what percent must the volume be decreased relative to the volume? Remember this, it's very important. To increase the pressure by 25%. So the pressure is increased by 25%. How much pressure is in the bottle? Well, there's 1.25 P now in the bottle. And let's let A be the percentage that it must go down for the V. So 1.25 P times the percentage of V that must go down. Notice, A is not the percentage of V that will give the product of 1. A is the percentage that must be decreased in relative to V to give a product of 1. Hence, A times V will be equal to 1 over 1.25 of P, which will give 100 over 125 P, which is the same thing as if we divide both sides by 25, 4 over 5 P. So, which is the same thing as 0.2 P, meaning that the new percentage that must be decreased, remember, that must be decreased. It is not the percentage of V that will give a product of 1. It is the percentage that we're decreasing it by. Must be 20% of P. So A must be equal to 20% because it's getting subtracted by 20% of its original volume. And by how much 20% subtracted will be left in A? Well, after we decrease it by 0.2 divided by V should give 0.2. So we must decrease it by 20%. So this is why I didn't solve for A, which is the exact quantity of V left after we increase the pressure by 1.25, because that's not what the question is asking for. How much must the volume be decreased? I cannot emphasize enough. How much must it be decreased? It is not the percentage left. And when I first did this, I fell into the same mistake that I'm telling you of. So this is why I have to emphasize this a lot. So A must be decreased by 20% less of P. Hence, it must be decreased by 20%, the solution to our question.